Let's continue our lecture video in integral calculus with the topic logarithmic function. Here at number 5, so we have here integral of sine 2t dt over 4 minus 3 cosine 2t. Now let's use again the pattern. Integral of du over u is equal to ln u plus c. Now let's have the u here equal to the denominator 4 minus 3 cosine 2t. The derivative of u is equal to derivative of 4, 0 minus 3. Derivative of cosine is negative sine 2t, then the derivative of the angle 2t, which is 2dt. So du is equal to positive 6 sine 2t dt. Now let's have the pattern. So we have here integral of du, which is 6 sine 2t dt. So that is the du over the u, which is 4 minus 3 cosine 2t. And since there's no 6 in the given, so we will balance this by putting 1 over 6 before the integral sign so that we can cancel out 6 and go back to the given. Okay, since we were able to satisfy this pattern, then we will now proceed to the pattern for the answer, which is ln of u plus c. So this is now equal to 1 over 6 ln of u, which is 4 minus 3 cosine 2t plus c. So this is now the answer. Now for checking by differentiation, so let's find the derivative of the answer. Derivative of 1 over 6 ln of 4 minus 3 cosine 2t plus c. So that is equal to 1 over 6. Derivative of ln is the derivative of 4 minus 3 cosine 2t, which is the derivative of u. That is equal to 4. So it is 0 minus 3. This becomes negative sine 2t times the derivative of u, which is 2, all over 4 minus 3 cosine 2t plus the derivative of constant c, which is 0. So this becomes 1 over 6 and this becomes positive 6 sine 2t all over 4 minus 3 cosine 2t. Cancel 6, so that is equal to sine 2t all over 4 minus 3 cosine 2t. So this is same with the given, therefore this answer is correct. Okay, so that is for number 5. Let's go to the number 6. For number 6, we have integral of x raised to 3 dx over x minus 1. So how do we deal with this one? Now notice that the power of the numerator is greater than the power of the denominator. If that happens, well, we can actually divide the numerator with the denominator. So we can have here x raised to 3 divided by x minus 1. So we put here x squared, so that if we multiply this with x minus 1, the answer becomes x raised to 3 minus x squared. Then put negative sign, and then this becomes reverse positive sign. So this one is 0, but we will not put it. So we have here bring down x squared. Then since we have here x squared, this is still greater than the power of the denominator. We can still continue with the division. So if we multiply x minus 1 with positive x, so we have here x squared minus x. So that is, put negative sign here, then put positive sign here, because we have here a negative sign, so we will be putting a positive sign. So this is 0. Then bring down x. We can still divide this with the denominator because they have the same power. If here has a lesser power than the denominator, then we cannot divide it. So we can still put here positive 1. If we multiply 1 with x minus 1, we get x minus 1. So put here a negative sign. We have here a positive sign. Bring down 1. So the remainder now here is plus 1 all over x minus 1. Take note that we cannot divide this further because the power here is actually x raised to 0, which is less than the power of the denominator, which is 1. Okay? So we can rewrite here as we can rewrite the given as the integral of x squared plus x plus 1 plus 1 over x minus 1 dx. Okay, so let's move this here. So distribute integral sign and the dx. We have here integral of x squared dx plus integral of x dx plus integral of dx plus the integral of dx over x minus 1. Okay. So we can notice we can use power formula here, here, and here. But in this portion, we can use logarithmic function. So using the logarithmic function, use the pattern again. Let's follow that pattern. So u here is equal to x minus 1. du is equal to dx. Since the pattern here has been satisfied, then the answer has this pattern, ln u plus c. So we have here x raised to 2 plus 1 over 2 plus 1 plus x raised to 1 plus 1, 1 plus 1, plus we have here x raised to 0 plus 1 over 0 plus 1 plus ln of x minus 1 plus c. So that is x raised to 3 over 3 plus x squared over 2 plus x plus ln of x minus 1 plus c. So that is now the answer for number 6. Next, let's proceed to number 7. For number 7, let's try to use here, if we put here u is equal to x plus 2 using powers. For example, if we have here x plus 2 raised to negative 2, then x plus 6 dx. Let's see if we can use powers here, power formula. So du here is dx. So that is equal to u of x plus 2 raised to the exponent negative 2, and then du here becomes dx. So x plus 6 is missing, therefore we cannot use the power formula. So what can we use here? If we use u, is equal to x plus 2 squared, therefore du is equal to 2 x plus 2, then we have there dx. Using the pattern for logarithmic, integral of du x plus 2 dx all over x plus 2 squared. So we cannot use this also because x plus 6 is missing. So no, this is wrong. So how will we solve it then? So notice that the only problem that we're having is that whenever we attempt to solve using powers or logarithm, there's no x plus 6. So then, let's use another technique. So we can use this trick. Since we have here x plus 2 squared, then might as well have an x plus 2 in the numerator. So x plus 2, then plus 4 dx. So that this is still the same with the given. Then you can separate it. So we have here integral of x plus 2 dx all over x plus 2 squared plus 4 integral of dx all over x plus 2 squared. And this is still the same with the given. Then we can integrate them separately. What happens here in the first one is that we can cancel out x plus 2. So it becomes dx over x plus 2 plus, now this one becomes 4 integral of x plus 2 raised to negative 2 dx. We cannot use logarithmic here since in the previous video we were able to see that we need a power of 1 for the denominator. So since the power of the denominator in this example is 2, therefore we cannot use logarithmic function in this second term. So we will be using power formula for the second term. So here we will be using u is equal to x plus 2, then du is equal to dx. We can use logarithmic function there, while we have here u is equal to x plus 2, du is equal to dx for the power formula. Okay, so we have here, so having satisfied this pattern, we will now have the pattern for the answer as ln u plus c. So ln u, which is x plus 2, plus we have here 4. Then we have there the power, which is x plus 2 raised to negative 2 plus 1 all over negative 2 plus 1. Okay, and then don't forget plus c. So that is now equal to ln of x plus 2, this is plus 4 of x plus 2 raised to negative 1 all over negative 1 plus c. So the final answer here is ln of x plus 2 minus 4, or we can already put it here, 4 all over x plus 2 plus c. Now checking by differentiation, we have the derivative of the answer, which is ln of x plus 2 minus 4 x plus 2 plus c, that is equal to, this is the derivative of the u, which is 1 over x plus 2, minus, this is actually similar with minus 4 x plus 2 raised to negative 1. So this becomes 4, bring down negative 1, x plus 2, negative 1, negative 1. Derivative of inside is 1. Plus derivative of c, or constant, is 0. This is equal to 1 over x plus 2. This becomes positive 4 x plus 2, negative 2. Then 1 over x plus 2 plus 4 all over x plus 2 squared, that is equal to x plus 2 squared. This is x plus 2 plus 4, therefore x plus 6 all over x plus 2 squared. So this is similar with the given. Therefore, this answer is correct. So that is for number 7. Let's go to the last example, number 8. For the integral of dx over square root of x times 1 plus square root of x. So if we rewrite this one, this is similar with dx all over x raised to 1 half times 1 plus x raised to 1 half. Okay, then let's try to use the pattern for logarithm. Du over u. So let u here equal to 1 plus x raised to 1 half. So let's try that. Du is equal to 0 plus 1 half x raised to 1 half minus 1 dx. It is equal to x raised to negative 1 half over 2 dx. Or that is dx over 2x raised to 1 half. So following the pattern for the logarithm, we have there integral of du. The du here is dx all over, or we have here, let's first write down u, which is 1 over 1 plus x raised to 1 half. So that's the u. While the du is dx all over 2x raised to 1 half. So looking at this is similar with the answer, with the given, except for the presence of 2. Now to balance, we will put 2 outside the integral sign. So disregard this portion here. So since we were able to get the pattern, or to accomplish this pattern, therefore our answer will have this pattern. So 2 ln of 1 plus x minus x raised to 1 half plus c. So that is the answer. Or so you can have this answer as raised to 1 half, but we can also have 2 ln of 1 plus square root of x plus c. They're similar. Checking. Let's see if what we did is correct. Checking by differentiation. Derivative of the answer, 2 ln of 1 plus x raised to 1 half plus c. So it is equal to 2 derivative of u, which is 1 half. This is 0 derivative 1 plus 1 half x raised to 1 half minus 1 all over 1 plus x raised to 1 half plus derivative of c is 0. This is equal to 2 raised to so this becomes x raised to negative 1 half all over 2 times 1 plus x raised to 1 half. So cancel 2. What's left is 1 all over x raised to 1 half 1 plus x raised to 1 half. So this is similar with the given. Therefore, these answers are correct. So that's for number 8.